Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from three-dimensional geometry, right? Although we have discussed all these concepts in our earlier videos, but here just for the sake of some learners, we are going to solve some important problems, right? So here today we'll discuss the concept of reflection of a point in a line, right? Or in other words, we can say that we have to find the image of some given point with respect to a given line, right? So let us start, and let us first have a rough diagram of this situation. So here we have a line. This is the line L. We can denote it by L, and here we can write the equation of the line. So the equation of this line can be rewritten as x minus 1 over minus 2, and this term can be written as y minus 2 over minus 1, and this term is z plus 1 over 1, right? So we have written this equation in this form because the standard or the symmetric form of the equation of the line is x minus x1 over a, y minus y1 over b, and z minus z1 over c. And here the equation is given like this: 1 minus x over 2, 2 minus y, and z plus 1. Right? So what we have done, we have written 1 minus x as x minus 1 and taking this negative sign in the denominator. Then we have y minus 2, that is we have taken this negative sign common, and here we have 1, so taking negative sign in the denominator, and then we have z plus 1 over 1. Right? So this equation is same as this one, and here we can take some scalar lambda, right? And here this scalar lambda is taken because we may have to find out the coordinates of the general point lying on the line, right? Okay. So now here we have to find the reflection of this point, right? So let us take this point as P, and the coordinates are 0, 3, minus 2, right? And when we say that we have to find the reflection of this point under this line, it means that this line L will act as a mirror, right? And we have to find the image of this point P with respect to this mirror, and the image may lie somewhere here, right? So this is Q point, and let us take the coordinates of the reflection of this point Q. Q is the reflection, right? Reflection or the image, right? So the image of this point P is Q, and let us take alpha, beta, and gamma as the coordinates of this point Q, right? Okay, so now what we will do, we'll join P and Q, right? We'll join P and Q, and we'll see that this line PQ will intersect this line L at this point, right? And let us take this point as M, right? So M is the point which is common to this line PQ and this line L, right? So this point M lies on this line L, and from this equation we can find out the coordinates of this point M, right? So we can find out it like this, that is we can write x minus 1 over minus 2 equal to lambda, that is we'll take x minus 1 over minus 2 is equal to lambda, then y minus 2 over minus 1 is equal to lambda, and z plus 1 over 1 is equal to lambda, right? So from this equation we'll have x is equal to minus 2 lambda plus 1. From here we have y is equal to minus lambda plus 2, and from here z is equal to lambda minus 1, right? So viewers, the values of x, y, z are given by these three terms, and here we have minus 2 lambda plus 1, then we have minus lambda plus 2, and we have lambda minus 1, right? So for some value of lambda, this point m, it will lie on this line L, right? Because this method, when we take a scalar as lambda and we adopt this method is primarily used for finding out the coordinates of the general point lying on a line, right? So here for some value of lambda, the point M will lie on this line L. So now viewers, our next step is to find out the DRs of this line L, right? So the DRs, the direction ratios of the line L are given by these three numbers in the denominators, right? So we have minus 2, minus 1 and 1 are the DRs of this line L, right? And since this line PQ is perpendicular to this line L, right? So PQ or PM is perpendicular to this line L. Now let us find out the DRs of PM, right? So DRs of the line PQ or PM can be obtained by subtracting the coordinates, right? So this point is minus 2 lambda plus 1, this point is 0, so minus 2 lambda plus 1 minus 0, then we have minus lambda plus 2 minus 3, and then we have lambda minus 1 plus 2, because here we have minus 2, right? So we have minus 2 lambda plus 1, here we have minus lambda minus 1, here we have lambda plus 1, right? So see, we have P and M, right? So we know that whenever we have 2 points on a line, that is x1, y1, z1 and x2, y2, z2, then the DRs of the line PM can be obtained by subtracting the coordinates, the respective coordinates, right? So y2 minus y1 and z2 minus z1, right? So here we can take this as x1, y1, z1. This point can be taken as x2, y2, z2, right? So the DRs of L are given by these numbers and DRs of PM are given by these numbers. So once we have obtained the DRs of the line L and PM, we see that PM is perpendicular to L, right? So PM is perpendicular to the line, and we know that if the DRs of two vectors A1, two vectors are A1, B1, C1 and A2, B2, C2, right? Then if the two vectors or the two lines are perpendicular, then the condition is A1, A2 plus B1, B2 plus C1, C2 is equal to 0, right? So this condition will be used to find out the scalar lambda, right? So this these numbers, that is DRs of the line L, may be taken as A1, B1, C1, and these DRs may be taken as A2, B2, C2, right? So now A1, A2 plus B1, B2 plus C1, C2 equal to 0 is the condition for the perpendicularity of two vectors, right? So now we have A1, A2 means we have minus 2 times minus 2 lambda plus 1, then we have B1, B2 minus 1, then we have minus lambda minus 1, then we have 1 here, we have lambda plus 1 is equal to 0, right? Now this is a simple linear equation in lambda. So we have 4 lambda minus 2, and here we have lambda plus 1, then we have lambda plus 1 is equal to 0. So we have 4 5 and 6, right? So 6 lambda, here we have 1 plus 1 is 2, and so this is minus 2, and 1 plus 1 is 2, that is equal to 0. So 2 and 2 get cancelled, so we have 6 lambda is equal to 0, and here lambda is equal to 0, right? So we have got the value of lambda as 0, right? So now if we take lambda is equal to 0 here, then the coordinates of m, the point m, which is the foot of the perpendicular, right, is given by minus 2 times 0 plus 1, then we have minus 0 plus 2, then we have 0 minus 1, right? And simplifying it, we have 1, here we have 2, and here we have minus 1, right? So now the coordinates of the point M are given by 1, 2 and minus 1, right? Okay, so this point M is the foot of the perpendicular, which is drawn from this point P to this line L. So viewers, once we have got the coordinates of this point M, we can easily find out the coordinates of this point Q, right? Because see, M is the midpoint of PQ, right? M is the midpoint of PQ, right? Because Q is the image or the reflection of this point P, where this line L is acting like a mirror, and the distance of the object and the image are equal from the mirror, right? Or in this case, this is the line, right? So now M is the midpoint, so here we have point P, here we have M, here we have Q. So P is 0, 3, minus 2, M is 1, 2, minus 1, Q is alpha, beta, gamma, right? Now here PM is equal to MQ, so this means the distance PM is equal to MQ, M is the midpoint, so we can apply the midpoint formula. So if we take this point as x1, y1, z1, this as x2, y2, z2, this is x, y, z, then x can be written as this point is x1 plus x2 over 2, right? So x is the average of x1 and x2, y is the average of y1 and y2, and z is the average of z1 and z2, right? So now here we'll make use of this equation. So x is 1, so here we have 1, x1 is 0, and x2 is alpha over 2, right? And if we solve it, so alpha is 2, right? And now let us solve this equation. So y is minus y is 2, and y1 is 3, and y2 is beta, right? And here we have 2. Now if we solve this equation, we'll have beta is equal to 4 minus 3, that is 1, right? So beta is 1, and now we can find out the value of gamma. So here z is z1 plus z2 over 2, and z is minus 1, so we have minus 1 here, and z1 is minus 2, and z2 is gamma over 2, and this is gamma is minus 2 plus 2, that is 0, right? So gamma is 0. So the coordinates of this point Q, which were assumed as alpha, beta, gamma, are now given by 2, 1, 0, right? So viewers, this is how we solve this problem, and here the given point was P, and the image is Q, whose coordinates are 2, 1, 0, right? And in this problem we have seen that there are a lot of concepts related to three-dimensional geometry were used.